Hi all, let's go over the answer for this worksheet. Okay, first, make sure you read it carefully. You have two functions. One is the g function, one is the f function, and g is the square root of f. And then here they give you two questions. One is for linear function, one is for quadratic. Okay, for linear function, we know the domain and range is all real number. Then what will be the domain and range for the square root of the linear function? So let's make a sketch. You have the y-intercept as 8. The slope is -4, which would go this way, which means you have 0 at 2. So that's important. So now if you make a square root function, you have two invariant points, 0 and 1, and then the graph will go like this, something like that. So that will be this function will be your g of x, right? This linear is your f of x. So you visualize a graph, you put in a graphic calculator whatever way you want. So the domain will be x is to the left of 2, okay? And y is above 0. So that will be the answer. You can also write this. It just means y is like the number is real number and then it's less than 2. Okay, for this one, now again you visualize it. You have a vertex at 0, 7. The graph open down. So where does it cross the 2, 0? Well, to answer the domain and range question for the quadratic, it's all real number for quadratic, and y is less than 7. Okay. Now, when you draw the square root, you have 4 invariant points, and then you have something like that, right? Something like that. So where do they cross? They cross at root 7 and minus root 7. Like you just solve this, you find out the 0. So the domain is from root 7 to 7. The question says use exact value, so you just leave the answer in square root form. And then this point is at 7, and then when you square root that is at root 7 as well. So y is between 0 and root 7 for the second part. You can also say all real number, or you don't need to, okay? It's assumed. Okay, so let's look at other question. Next question. Okay, next, to sketch the graph, again, linear, you have two invariant points, 0 and 1, all right? When the y value is 0 and 1, this 2 point is where they intersect. Between 0 and 1 and go above, okay? Now, this is another point that is 4, and you square root it, become 2. So this is another point you can graph accurately. So the rest will be just like this, okay? On this side, the 0 stay, the 1 stay, right? The 4 will become 2. 4 become 2. So those 6 points are your guides. Between 0 and 1 is above, and then it goes there. Above, and then go below, like this. So this is your answer for the function. All right. Let's move on. Circle the right word. When the function is less than 0 and 1, between 0 and 1, the square root of the graph will be above. The square root will be above the f of x. They equal when the function is equal to 1 or 0. So those are the invariant points. Suppose you have this graph and it's positive. We say this is bigger than that whenever f of x is the original function is bigger than the square root function whenever f of x is bigger than 1. Okay? All right, next page. Look at this table. Okay, now we're working on rational functions. Write the equation of asymptotes is applicable, or write NA. Now, when you have a function like this, the shortcut, you have a horizontal asymptote at 3 and 2. Okay, horizontal asymptote. Y equal to 3 over 2. That's the shortcut. You look at the coefficient. How about the vertical asymptote? You look at the restriction. X cannot be, well, or X is 1 over 2 is your answer. All right. Finally, point of discontinuity. There's no point of discontinuity here. You only have point of discontinuity when you can look at the second example. When you can cancel that out, then you have a point of discontinuity. Okay. So Yeah, the number keep disappearing. So, okay, anyway, these two are the same. So the point of discontinuity is at 2. All right. And then you plug in the 2 in the remaining equation, which is x plus 2, which give you 4. The horizontal asymptote. Well, because the graph is just a linear function, so there's no horizontal asymptote, there's no vertical asymptote. Here, this graph, the bottom cannot not be 0, so there's no vertical asymptote. And then whenever you have like for example, 1 over x, right? Whenever you have a smaller degree on top than the bottom, your y equal to 0, the x-axis is always your horizontal asymptote. This is also in the notes. You can check that out. Finally, there's no point of discontinuity. Okay, this one combined both. It has a point of discontinuity at 4, right? At 4. The remaining function is x plus 5, x plus 3. So plug a 4 there into the x. You have 4 plus 5 is 9, 4 plus 3 is 7. So that is your point. X plus 5, x plus 3, look at the leading coefficient. The horizontal asymptote is 1. Okay? Or you can try to change the formula, you see. Finally, x plus 3 will be your the source of your vertical asymptote. Okay? All right, this table summarize different types of rational expression. Finally, rewrite this in this form. Sure. So we learned that let's write the top as the multiple of this. Since you start with a 2, so you double 2 minus 3 is 2x minus 6. I need a 2x minus 6, but I only have 2x minus 1, so I minus 6 plus 6 minus 1. Okay? So I don't know what happened to the software. Okay. And then over x minus 3. And then you separate it. So something wrong with the software. Okay, here we go. You separate it here and there. So the top, the first part become a 2. The second part will be 5x minus 3. Okay, so let's draw it. So we'll finish x minus 3. Okay, so the asymptote is at 3, right? The horizontal asymptote is at 2. Finally, the vertical expansion is 5. So instead of at 1 here and there, it is where without any expansion, this is where the graph will be. But now you multiply by 5. So instead of going 1, 1, you go 1, 5. 1, 2, 3, 4, 5 is here. And instead of going this way, you go 1 and then 5. 1, 2, 3, 4, 5. So it's here. So with those 2 points, you draw your curve. Okay, so that will be your answer. You can graph it and you can check. Okay, so here, hopefully you learn from this worksheet and then you can continue to work on the practice test. Okay, bye-bye.